Drop a cup on the floor. It shatters, pieces scatter everywhere. The sound of something irreversibly destroyed. Now, just sit there and wait. Wait for the pieces to magically jump back up, fly through the air, and perfectly reassemble themselves in your hand. You can wait as long as you want. It's not going to happen. You know it. I know it. But why? Why do things in our world only happen one way? It's completely obvious that the phenomena of the world are irreversible. Waves break on the shore, but the foam never collects itself, rises up, and jumps back out to sea. Our very experience of life is one-sided. We remember the past, but we don't remember the future. We feel regret for what has happened, and hope for what might happen. The past and future are completely different. So, you'd think the laws of physics, the rules that govern the atoms that make up everything, must have some kind of one-way street sign built into them. Some fundamental principle that says, this way forward, no U-turns allowed. But here's the crazy part. We haven't found it in all the laws of physics we know, from gravity to electricity. There's no distinction between past and future. A movie of a planet orbiting the sun looks perfectly normal whether you play it forwards or backwards. The laws are time reversible, so if our fundamental laws work both ways, why does our world only go one way? Why am I speaking to you, with my voice going out into the air, instead of the air sucking words back into my mouth? The answer has to be somewhere else. Let's look closer. Imagine a tank of water. On one side, we have blue water, like ink, and on the other side, clear water. We pull out the divider. What happens? Gradually, the blue mixes with the white until the whole tank is a uniform, light blue. Now, if we watched a movie of this happening and played it backwards, it would look absurd. We'd see a tank of light blue water spontaneously separate itself into dark blue on one side and clear on the other. That just doesn't happen. But now, let's zoom in, way in, down to the level of individual molecules. We see blue molecules and white molecules bouncing around, colliding with each other like tiny billiard balls. If we watch any single collision, it's perfectly reversible. A blue molecule hits a white one and they bounce off. Run that tiny clip backwards, and it still looks completely normal. Two molecules come together and bounce apart. The laws of physics are perfectly happy with that. So, if every single interaction is reversible, why is the whole process irreversible? Because of statistics. Sheer probability. There are countless ways for the molecules to be mixed up, but there are very few ways for them to be separated. When you start with them separated and let them bounce around randomly, they're naturally going to wander into one of the trillions of mixed-up states. It's just overwhelmingly likely. But for them to start in a mixed-up state and, through random collisions, all end up perfectly separated on two sides, it's not impossible. It's just so mind-bogglingly, astronomically unlikely that you would have to wait longer than the age of the universe to see it happen. And that's the secret. The irreversibility we see isn't a fundamental law of physics. It's just a consequence of starting with something ordered and letting nature's randomness take over. Things don't go from messy to neat on their own, because there are just way more ways to be messy. This leads to the biggest question of all. If things always go from ordered to disordered, how did the universe get so ordered in the first place? Why did it start in such a special, neat, low entropy condition? Because that's what the evidence tells us. Every time we look out into space, we see an ordered history. We can predict that a new star we find will look like other stars, not just a random mess. The success of sciences like geology and history relies on this idea that the past was more ordered, allowing us to read its traces today. So, to make sense of our world, we have to add a special condition, a historical fact, to the laws of physics. We have to assume the universe began in a highly ordered state. That initial condition, that one-time starting pistol, is what gives time its arrow. It's why the universe has been unwinding, getting more disordered ever since. It's why entropy always increases. Think of it like this. You have a stack of towels at the beach. A sudden rainstorm soaks everything. You and the towels are all wet. You try to dry yourself with one towel. It helps a little. You try another, but it's just as damp as you are. Soon, you realize you can't get any drier, because the towels has reached the same level of dampness. There's no difference to work with. That dampness is like temperature. The ability to get dry is like available energy. Energy is always conserved, but its availability is not. To do useful work, you need a differencer, hot thing and a cold thing. But nature's tendency is to smooth out those differences. Hot and cold things left together become lukewarm. The total energy is the same, but its usefulness, its availability, has decreased. This is the law of entropy. The total disorder of the universe, the total unavailability of its energy, is always increasing. This one-way flow, this constant move towards equilibrium, is the reason for everything. It's why you have memories. It's why things break and don't unbreak. It's why we age. The fundamental laws themselves are like a road that can be traveled in either direction. But the universe started at one end of that road, the ordered end, and has been driving in one direction ever since. So, why can't the broken cup put itself back together? It's not because the laws of physics forbid it. At the atomic level, every piece could theoretically reverse its path. The real reason is probability. The universe started in a state of incredible order, and it has been moving towards disorder ever since. That one-way journey is the arrow of time, and the reason for that initial ordered state that remains one of the greatest mysteries in all of science. Thanks for watching. If this changed how you see the world even a little bit, consider subscribing for more deep dives into the nature of reality. See you next time.